Hi all, here we are with guided practice 21. We are using exponentials and logs to solve equations with powers in them, okay? And so we're using the fact that exponentials and logs are inverse operations. So in number one, we want to solve using a common logarithm. So that means I'm using a log base 10, but we don't have to write the 10. And we're then going to use properties. So anytime you see something where you have a number in a base and a variable and an exponent, you're going to use a log to get you out of that situation. So in this case, we're going to take the log base 10 of both sides. Now I'm going to go ahead and use that log property where I am taking that exponent and moving it out front. Okay, and that means what we get here is negative x squared log of 3 equals the log of 7. Now remember the base on those logs is 10. Now that I've got my exponent, my variable out of the exponent, then I want to solve for that exponent. So the first thing I want to get rid of here is the log of 3. In fact, negative log of 3. So let's divide by negative log of 3. What that does is leaves us with just the x squared, and we have negative log 7 over log 3. And then we're going to go ahead and take the square root of that. So x equals the square root of negative log 7 over log 3. And we get positive and negative that answer. Now, let's check to see if that makes any sense. So let me grab a calculator here and say, okay, so we want the log of 7 divided by the log of 3. And we want to make it negative. Oh, back that up. Hold on, sorry, I haven't used this one in a while. Try to start over. So let's start with negative log of 7 divided by log of 3. I know this is not the calculator you have, but this is what's on my iPad. And it does give us a value here, but it is negative. So taking the square root of it does not make any sense. And so that means we actually get no solutions here. Okay. All right. Next. This time we're going to do the exact same thing using our common logarithms. So we're going to start out by taking the log of both sides. And then I'm going to use that same strategy where I'm taking this exponent and moving it to the front on both sides. This will give you 5x plus 5 times the log of 2 and 2x plus 1 times the log of 3. Now remember, anytime you have two terms added together, you're going to keep them together in parentheses. Now we go ahead and distribute those logs into the parentheses. It doesn't matter whether your log 2 or log 3 is on the front or the back, it can still get distributed inside. So this is 5 log 2 times x plus 5 log 2. Now, why did I write it that way? Well, because the log of 2 is a number, and I want a number in front of my x so that I can know what to divide it by. On the other side of the equation, we have 2 log 3 times x plus log 3. And now I still have two x terms. So I have an x here and an x here. So I want to move those terms on the same side and other terms away from it. So I'm going to subtract the 5 log 2. And I'm going to subtract the 2 log 3 times x. That will give me 5 log 2 times x minus 2 log 3 times x. And on the right-hand side, we have the log of 3 minus 5 log of 2. Sorry about my handwriting, it's going a little silly. Now I've got an x in each of these terms, so I can think about factoring it out. So I'm going to take the x to the front, and what's left is the 5 log 2 minus 2 log 3. The right-hand side doesn't change, so it stays log 3 minus 5 log 2. Now I want that x by itself, so I'm going to divide everything by what's in the parentheses. So divide by 5 log 2 minus 2 log 3. And that gives us a final answer of x equals that whole expression. So log of 3 minus 5 log 2 over 5 log 2 minus 2 log 3. And we can put that into the calculator and get a value. I'm going to hold off on that for now, but we can do that. Now, number 3 asks for the same thing, but instead it asks you to use natural logarithms. So that means instead of using log, we're going to use ln. So you're going to take the ln of both sides. We're going to use that same move where we take this exponent and move it down in front. So you'll have 5 minus x, keep it in parentheses because it's two terms, and an ln2 equals ln6. We'll go ahead and distribute that ln2 inside the parentheses, and that'll give us 5 ln2 minus ln times x, ln2 times x. Now, I only have one x here. It's right here. So I just want to move everything away. So I'm going to subtract the 5 ln2. Excuse my sneezes. Minus 5 ln2, both sides. That'll leave me with negative ln2 times x equals ln6 minus 5 ln2. And then the only thing I need to get rid of then is the negative ln2 that's in front of my x, and I'll have my x by itself. So that means we get a final answer of x equals ln of 6 minus 5 ln2 all over negative ln of 2. And we're going to leave that as our final answer. Again, you could put that in a calculator and get a value, but we're going to save time and not do that. On to number 4. Same thing here. We're using a natural log here as well. So take the natural log of both sides. And then we're using that trick where that exponent comes down in front of the ln. So you'll have 4x minus 1 times the natural log of 3, and that's equal to the natural log of 5. Next, get rid of those parentheses. So we distribute inside our ln3, and we'll make that 4 ln3 times x minus the natural log of 3 equals the natural log of 5. From here, we've got a single x to solve for. So we're going to get rid of the ln3 first. So let's add it to both sides. And that will give us 4 ln3 times x equals ln of 5 plus ln of 3. And then the only thing left to do is to get rid of that 4 ln3 that's in front of our x. So divide it on both sides. And that'll leave us with a final answer of x equals ln 5 plus ln 3 over 4 ln 3. And you can start to see these have kind of like a formula to them. Okay. All right, on to number 5. All right, so here's the thing. I want to use um, the opposite, the inverse function to get rid of my logs here. But I can only do that if I have a single log on one or both sides. So what I'm going to have to do is combine some things.